to see the Unit 5, that is case studies in artificial intelligence. There are various case studies depending on the department. They split here in the syllabus. So this is the syllabus of Unit 5, disease prediction, sharecast or share price forecasting, weather prediction, domain-specific case studies. For CSE, they gave sentiment analysis. For EC, they gave smart homes using AI. For EEE civil and mechanical department, they gave for renewable energy, application of ML, and predictive maintenance and all. So now I'm going to focus on the first topic, disease prediction. First introduction, I give why predictive analysis. So what does predictive analysis means? It's a data analytics tool that uses historical data, statistical algorithm and machine learning techniques to predict the future outcomes. For example, the trade base. What is the trade market today? What is the trade market tomorrow? We can analyze and predict some scores, right? So that is, for example, gold rate. It is keep on increasing from the year 2020 to 2025, how the gold rate is increasing. Now several businessmen and traders are predicting that in 2030, before 2030, it will reach to higher prices, right? So it helps the business and organizations to make informed decisions by identifying the trend, pattern, and potential risk. So that is predictive analysis to predict the future outcomes, okay, in simple terms. So how this predictive analysis is going to work? First, we have to collect the data, okay, based on the past data and real-time informations. We have to collect whatever the example, either it is here I'm giving sales records, sensor data or customer interactions, everything based on customer new startup company or anything we can do in this particular data collection. So next one is data processing. So data processing, in the sense we are going to process the pre-processed informations, that is cleaning, organizing and transforming the data to remove errors and inconsistencies. That is data processing. Next one is model building. Model building is nothing but we are going to use some machine learning and statistical models, right? So that is regression, decision trees and neural networks. Fourth one is prediction and interpretation. It generates the forecast and insights for decisions making. And final one is continuous improvement. We have to update the model with new data each and every time. So how this is working? First one is data collection using Kaggle website. For our objective, we are going to collect some data sets, right? Then data pre-processing, nothing but cleaning and removing unwanted informations, and you are going to normalize the data for our objective. Next one is model building. We are going to use any machine learning algorithm, either it's a supervised algorithm or unsupervised algorithm. According to our objective, we are going to build the model and the algorithm. And fourth one is prediction and interpretation, nothing but your results, accuracy, how your precision is there, how your confusion matrix is there, how your error score is there. Everything you have to calculate. That is the prediction and interpretation. For that particular results and accuracy, you are going to improve that particular results as a continuous improvement for deploying the model, and you are going to give the model for client presentation. That is the final deployment, okay. You are going to maintain some accuracy for this continuous improvement. So what are the various applications of predictive analysis? It is used in healthcare application, finance, retail, manufacturing, weather forecasting, and in education departments also several colleges are using this predictive analytics for admission purpose and everything, right? So here I'm giving one example. First one is disease prediction. So first, for disease prediction, how this model will work. Define the objective. First one is determine the specific disease to predict diabetes or cardiovascular disease. Here I am taking that. For that particular objective, I am going to collect the data. Second one is data collection. For patient data sets, we are going to download that particular data sets, any form of website like Kaggle or any other website. So here they are taking the genomic data and data pre-processing, nothing but cleaning and normalizing the data and finally encoding the data, that is converting categorical variables into numerical format. Why we are going for that? For prediction accuracy we are going for that. And fourth one is future selection and engineering, identifying the relevant variables that influence the disease prediction. And future engineering is nothing but creating the new futures by combining the existing one to capture the pattern, right? So future selection and future engineering based on the attributes and the data sets, we are going to predict the particular selection of algorithm, and we are going to predict the future of the existing algorithm. Okay, and next one is model selection. Model selection is nothing but we are going to use any algorithm, supervised algorithm or unsupervised algorithm. In supervised, either it is a logistic, decision tree, random forest, or unsupervised algorithm. KNN means neural networks algorithm. Whatever it is, we are going for that particular based on the data set and the problem objective. And finally, you are going to validate that particular data using k-fold validation. Why we are going for this k-fold validation? Everything is to prevent the overfitting, right? So next one is we are going to train the model. Nothing but training is 80% will be used for training and 20% of the data will be used for testing. You are going to fit the particular chosen model for the training data set, and you are going to use the hyperparameter tuning. Hyperparameter tuning is nothing but optimization of that particular data. If we are having 100 attributes, we need only 50 attributes, means we are going to optimize that particular model according to our objective. Finally, you are going to evaluate according to the matrices F1 score, accuracy, precision, recall on the ROC curve. Okay. Next one is validation. Test the model on separate validation set to evaluate its predictive power. And the eighth column is deployment of the model. Deployment is nothing but integration of various resources or modules for fine tuning into a single model. So incorporate the model into clinical decision support system to assist healthcare professional. That is the deployment. And final one is continuous monitoring and updating. What is continuous monitoring? We are going to track that particular model according to the feedbacks and the environment. So performance tracking and data updates, you have to update daily for that particular thing. Here we are taking patient data, means you have to track the patient data over time to analyze whether it is properly working or not, right? So these are the various steps in disease prediction. We are going to use this disease prediction as a case study. So it is used in cardiovascular disease, Alzheimer's prediction, cancer prediction. So this is an example whether we are working in as a case study. So we are going to import some necessary libraries as NumPy, Pandas, Matplot. For data visualization tools, we are using the Seaborn, and for metrics support, we are using this sklearn metrics app and tools. Okay. The next one is loading the data set. We are here, diabetes data set is taken. We are going to download some diabetes data set and it is taken. Okay. And for this, we are going to check whether the any missing values are there, or we are going to fill that values with NAN. So that is data pre-processing. That is any missing values or zero values in critical columns, we have to include the zero values and replace with NAN. Okay, not a number. Okay. This is the explanation of 3, and we are going for 4th, exploratory data analysis for visualization. We can visualize that particular data set in histogram tool or a bar chart or pie chart, anything we can use this, right? This is a correlation heat map for this particular data set. And we are going for future selection and scaling. In this future selection, we are going to split the data set as a training data set and the testing data set. As I said, 80% will be the training and 20% of the data will be always used for testing our data sets. This is future selection using training, and we are going to transform that data into trainer data as well as tester data. Okay. And finally, model building and training. We are going to build the model using any algorithm. Here they are using logistic regression algorithm, right? And we are going to train that particular model. Based on the training, we are going to evaluate the accuracy, confusion matrix and classification report based on that particular model. Calculating the accuracy, calculating the confusion matrix, and finally we are giving the classification reports. Okay. So in this summary, it will build a machine learning pipeline to predict the diabetes dataset using logistic regression machine learning algorithms. Okay, in this case study, we are using logistic regression as a diabetes dataset we are using for disease prediction, diabetes dataset. Okay, so for data loading, that is data loading, then data pre-processing, here cleaning and inputting the missing data, and finally visualization using any histogram or bar plot or pie chart, and future selection, that is the training and testing data as we are going to select for the scalar informations, and training the model based on that particular objective, and finally evaluating your model performance as the nothing but the metrics. Okay. So finally, you are going to interpret that particular result using accuracy, confusion matrix, and classification report. You are going to deploy the model. Finally, deployment to the client side, right? You're going to give that particular project to the client. That is model optimization. So this is the example of disease prediction. So several examples are there. In today's class, we see about this disease prediction example. Hope you are clear. Thank you.